Alright guys, welcome to our channel once again. Today we'll learn about aromatic hydrocarbons. So let us go ahead and consider the structure of the benzene. So the resonance theory says that benzene can be described as hybrid of two equivalent chemical structure, in which each carbon-carbon connection is midway between single and double bond. Now, the benzene cannot be represented accurately by either of these individual chemical structure. So the structure is somewhere between the two extremes. However, the modern benzene structure are more acceptable since they indicate the number of pi electrons. So if I have my benzene to be this, so this is what the benzene looks like. So this will show the modern structure of benzene. So the modern structure of benzene will be revealed to be this, which is also equivalent to this. Alright, so having known this, let us consider the chemical reactions of benzene. So electrophilic substitution reactions are characteristic of all aromatic ring, including benzene and substituted benzenes. So benzene has a ring with its 6 pi electron above and below. So these electrons are localized within the ring of benzene in a number of resonance stabilized structures. So this phenomenon explains why benzene undergoes electrophilic substitution reaction readily. In this type of substitution, the electrophile, which is E+, reacts with aromatic ring and substitutes for one of the hydrogen atoms. So let us consider a benzene ring here, and then let's say, like we know, we have our hydrogen atoms, our 6 hydrogen atoms. So if each reacts with an electrophile, a hydrogen will be substituted by this electrophile, so I'll have the electrophile replacing the hydrogen here. So while this is the outcome of the reaction. So many different substituents can be introduced into the benzene ring via nitration, sulphonation, halogenation, alkylation, and so on. So let us consider nitration of benzene. Now if I have a benzene here, So the electrophile in this reaction will be nitronium. So I'll go ahead and react this with nitronium ion. So if this reaction occurs, I'll have so if the nitronium ion reacts with this, when this hydrogen is lost, I'll have this double bond replaced. So I'll have this nitro benzene. So this process is important in the synthesis of dyes and pharmaceutical agents because the nitro substituted products can be reduced to arylamine. That's ArNH2. So next is the sulphonation of benzene. So sulphonation is favored in strong sulfuric acid where SO3 or HSO3 plus are the electrophiles and the sulfonating agents. So this reaction is important in the synthetic process, such as in the manufacture of detergents and manufacture of sulfur drugs. So let's consider the benzene here. If it reacts with H2SO4, now I have SO3 here and I have my hydrogen here. So the bond here is lost. This is carbocation. And then ultimately, if this hydrogen is displaced, I'll regain the double bond here. So I'll have benzene sulfonic acid. So that's it with that. So next, let's consider the halogenation of benzene. So a Lewis acid catalyst is required for most halogenation reaction. with the following reactivity order for the halogen. We have fluorine, chlorine, bromine, and then lastly iodine. So if I have my C6H6, that's benzene, plus chlorine, so a halogenation reaction will occur here. So I have my catalyst here, Lewis acid catalyst. So this will yield C6H5Cl plus then plus HCl. So next is the alkylation of benzene. So haloalkanes react with benzene in the presence of Lewis acid to give alkyl benzenes. The mechanism is similar to that of halogenation reaction and thus requires a Lewis acid catalyst. So if I have my benzene, so this reacts with methyl. Over here is a Lewis acid, where X is a halogen. So I'll have my methyl here and hydrogen here. So to complete this reaction, the hydrogen leaves for a double bond to occur here. So finally, I'll have this. And this becomes methyl benzene. Alright guys, thanks for watching this video. If you enjoyed it, please give it a thumbs up. Also ensure to subscribe to our channel and share the video with your friends. Thank you.